Okay, so the next thing we can do with the random forest, that we can do feature selection, that I have told you above, that we can do feature selection. That how we can do feature selection? Let's say you have some features f1, f2 and fn. Now you have different models also, this model 1, model 2 and model 3. So what you'll do, you'll try to break down the features and give it to different model. Let's say you give f1 feature to this model 1, f2 feature to this model 2 and fn feature to this model 3. So now after the prediction of the outputs, what you will do during the testing, you can during the training you can see that which all feature that gives you the correct output or most accurate output. Okay, and the feature with the least correct output, you can either discard it. Let's say there is some feature f4 and it doesn't performs well with the output, so you can basically you can discard it. Okay, another thing you can do with this is, let's say you have two features, let's say f5 and f10. Now these two features seems to be correlated, like they are almost giving the same output. Okay, and if and also you can use something like correlation matrix, and this seems to be correlated. Then this thing also you can do if you want to improvise the performance of the matrix, because you don't want your data to be redundant. You don't want that this should happen, that you are getting the same data and also not useless data. Okay, so you don't want your model to feed with the either redundant or useless data. So for this this thing you can use random forest, okay, and correlation matrix too. Now next thing here is what we have in our bag is called difference between random forest and decision tree. So I don't think there's much to explain about it. You already know that what random forest is and what decision tree. Decision tree is a single decision tree where each and every node makes a decision, okay, and at the end when you get pure split, you will basically classify that particular thing with the outputs. Okay, and random forest is just a combination of decision trees, multiple tens, hundreds, or even thousands. Okay, and it doesn't suffer overfitting, we know, and it is difficult to interpret, but decision tree is interpretable, and also you can use multiple decision trees to create random forest. So that's all for the decision tree part. Now next we are moving towards nearest neighbor. Okay, what nearest neighbor? That okay, let's move on with the practical implementation, because it's not a nearest neighbor video, but okay, the nearest neighbor is let me give a quick intro about nearest neighbor. Is that, let's say this is your data, these are some data points, and this is your another data point. So you will try to classify a given input, let's say this, based on the distance of the k nearest neighbor. Okay, so this is how that basically what we are doing, we are trying to assign this point a label with the help of k nearest neighbor. Okay, this is called weighted neighborhood scheme. Okay, so this is what happening, we are predicting based on the already provided input. This is what also internally works in random forest in some cases. So this is just a simple relationship, we doesn't need to look much on it, but this is how I explained you that random forest and k nearest neighbor. Okay, now next we'll be moving to importing libraries and try to run our model. Okay, so what we'll do, we'll import our libraries. Okay, sorry. So here I'll try to run this cell when it's trying to run the model. So what we are doing, we are just importing numpy as np, pandas and pd, and cborn as sns, and matplotlib.pyplot as pld. So numpy is just a linear algebra library you can just use to handle arrays and all. Pandas is for data frame thing. Matplotlib is for visualization purpose, and cborn is also a visualization tool basically used for statistics. Everything we are getting it from their respective libraries. Okay. In next line, we are just setting up the OS directory so that this is our input part and this is our output part. So this is all we are doing, and next we are just running to like filter the warnings and all. Now next thing, we are just importing the data. Okay, so this is our file input car evolution dataset, and we are importing it. Okay, before we move on learning further about the random forest, let us understand the use case. What we are trying to do here. Let's look at the CSV file, the dataset. Basically here you can see easily view. Okay, this are all other features. They don't have names, but let me tell you what exactly our dataset is doing. So here we are having our dataset. This is our dataset. There are certain class like 5 to 6 class, I guess, and there is one predicting variable that whether this belongs to some class or not. So what the dataset is all about, it's about cars. Okay, and we'll be predicting whether it's a good, a very good, or all. So what all the columns we are having like maintenance cost, number of doors in the cars, persons can sit, and safety also. So while you are buying a car, you should be aware of all these parameters, and based on that you'll decide that whether to buy this car or not. Okay, so this thing we are doing here, we are based on the input, we are predicting that whether this belongs to this class, you should buy it or not. Okay, so this is the thing we are doing here with the dataset. Okay, let's look out how big our dataset. So it is having 1728 data entries and 7 columns. Means out of that 6 are the independent features, and 1 is the dependent features. So what do you mean by dependent and independent? So let me give you a simple example of linear regression. This is x and this is y, and this is your line. So this is a coordinate, you can say x and y. So here x is the independent feature and y is dependent feature. Why? Because your formula is like y equals to mx plus c. So we are providing x as input and y as output. So the dependent feature is basically what? Nothing but the target variable. So based on safety measures, number of doors, the number of person can sit in that that car, will be predicting that whether this car is a good choice for buying or not. Okay, so this is the thing we'll be doing. So there are 7 columns. Out of it, 1 is the target and remaining are features. Okay, next we'll be looking and working with the seeing head of our dataset. So there is simple command .df.head will run, and this is how our dataset looks. It's not very good looking now because it doesn't have any column names. What all is doing. So in the next line, we'll be just replacing the column names with the actual values of the column. So this command we run, and these are the column names. And now if we see our dataset, what we'll find that it looks pretty good. That first column is buying or not, like whether the people are buying it or not. Okay, let me explain you the dataset a bit. So this column signifies that whether people are buying or it or not. Okay, so